Am I audible to all of you?
Good morning, sir.
Morning, morning.
Assalamu alaikum, sir.
Morning, Islam. Am I audible to all of you?
Yes, sir. Yes,
Yes,
sir.
sir.
My slide is visible, properly visible?
Yes, sir.
Okay. So we started unit number 3 on the last term, and this is all about sensors. And I tried to explain you what is sensor and what is the importance of it. So sensors are used basically to convert. Sensor is a device that converts one type of parameter into another suitable parameter, which basically facilitates the measurement of the desired parameter. So this is what sensor is, and then we are, as far as this course is concerned, we are more interested, means this converted parameter may be electrical or non-electrical. But here in this course, we are interested in only that class, that class of sensor which converts non-electrical parameter into the electrical parameter. Why this conversion is required? As I told you on the last turn, that means conversion, by converting it into the electrical parameter, we can measure the parameter with the good accuracy at lower cost. And then once your signal is converted into the electrical signal, then many more things can be done. I mean, it can be processed, further processed, and then it can be transmitted, and then it can be converted into the numbers. Then we can interface into the computer, and many more things can be done. So this is what basically the, but basic purpose is not the processing, transmission, and presentation, but main analysis. The main motivation is the accurate measurement. That is the essential thing. Accurate measurement at lower cost. That's why this electrical sensors, the class of sensors which converts non-electrical parameter into the electrical parameter. Now I'm starting with then classification. As far as the classification is concerned, so these sensors which converts non-electrical parameter into the electrical parameter can be divided into um, two categories. um, Passive sensors, passive sensors, and then active sensors. Passive sensor and then active sensor. This is our classification of sensors which converts non-electrical parameter into the electrical parameter. It is the classification for that class of sensor. Now this passive sensors can further be divided into a resistive sensor, inductive sensor, and capacitive sensor. This. And as far as the active and passive sensors are concerned, active sensors are those sensors which are self-generating type. You don't require any additional voltage source to supply the energy. They are self-generating type. The example is your Hall effect sensor, or your piezoelectric sensor, thermocouple. So you can see that all these kind of sensors, whatever, they are self-generating type of sensor, and they come in the category of active sensor. Now, these resistive sensors means the non-electrical parameter, this class of sensors, they convert non-electrical parameter into the resistance. Like your RTD, resistance temperature detector, it converts the temperature into resistance. Then inductive sensor, there are many inductive sensor which converts a non-electrical parameter into the electrical parameter. The example of inductive sensor is your LVDT, or you can have any coil which is performing the sensing application is an inductive sensor. Then capacitive sensor is again converts the non-electrical parameter into the electrical parameter. Capacitive sensor widespreadly used in chemical sensing and in level sensing also in a tank and all. So we'll discuss all these things one by one. So I'm starting with the strain gauge. So can anybody tell me what this is a kind of sensor? So what is the means? If anybody knows anything about the strain gauge, I want that you should reveal that. Yes, please. Anybody? Any idea about the strain gauge? Obviously, it is a sensor. नाम से कुछ बता सकते हैं? From the name.
strain measurement.
तो कुछ चेंज हो रहा होगा सर लेंथ में
Strain
के according?
measurement. Somebody so told strain measurement. That's correct. From name, strain measurement. Strain gauge, strain measurement. That's all. So this sensor, strain means deformation. It may be deformation in length, it may be deformation in width. So, and deformation within the elastic limit of the material, whatever material we're talking about. So this is what is called strain. So this obviously this particular sensor can measure the strain. It is sensitive to strain, and it is a resistive sensor. It is a resistive sensor. So it basically converts strain into resistance. Now by measuring the resistance, we can measure the strain. So this is your strain. Generally, strain is defined as change in length per unit length. It is, although it is one kind of but strain, it is longitudinal strain, but it may be other dimension deformation in other dimension also, but generally we refer this parameter as a strain. So this is strain gauge is sensitive to the deformation, sensitive to the strain, and it converts the change in this strain into the resistance. So it is written here, you can see strain gauge is a passive resistive transducer which converts the mechanical elongation and compression into a resistance change. This change in resistance takes place due to the variation in length and cross-sectional area of the gauge wire when external forces acts on it. So as far as the strain gauge is concerned, it is simple wire. It is a metallic wire or a and this or semiconducting wire made up of semiconducting material or metallic material. So this you see, this is a wire, very thin wire, and it is so thin that it is basically sandwiched in a piece of paper. Means two papers, in between two papers it is sandwiched, and it is so thin that it looks like a paper. And then whichever structure we want to sense the strain, we bond it to that structure. So obviously if there is any deformation in the structure, then this wire also got deformed, and because of the deformation in the wire, its dimension changes, and because of that its resistance change. This is how your strain gauge work. And one of the structures of the strain gauge are shown here. You can see these are the terminals. So this is what is called strain gauge. Now if anybody is having any question regarding whatever I told you about the strain gauge, you can ask, otherwise we'll move ahead. Whatever I told you, whatever revealed in this slide, it is important that because you should have the image or the concept of strain gauge, and on this concept we will discuss other things. What is a strain gauge? That should be clear. Now, you people must have studied in your school, I feel, that Hooke's law. So the for any material, um, the strain of the material is proportional to applied stress within the elastic limit of that material. Means the ratio of stress and strain is a constant that is called Young's modulus of elasticity. This law works only within the elastic limit. Once you cross the elastic limit, this law does not work, and your material, the deformation that takes place in the material, it will be permanent beyond the Hooke's law. So this is your Hooke's law. Now I'll explain the actually I would like to tell you a very important thing. You see, in a sensor, we, through the sensor, whatever measurement we make, we convert the parameter which we want to measure. Like we want to a parameter X, and we convert it into the another parameter through the with the help of sensor Y, and this parameter we measure using certain measurement technique. Now we are not interested in measuring Y. Our aim is to measure X. So how can we find the value of X? Yes, please. हाँ भाइयों बहनों बताइए, आप लोग कुछ तो बोला करें भाई.
सर y को x का फंक्शन बनाकर, मतलब
obviously
y.
that is हाँ ठीक है, बहुत अच्छी बात है, very good. So we want a relation between X and Y, है ना? And the process by which this is the universal requirement for any instrumentation system, sensor based measurement system. Instrumentation system means sensor based measurement system. This is the universal requirement. Wherever you use a sensor, then you require this kind of relation, obviously, because we are interested in finding out X, although we are measuring Y, because for the good accuracy we are converting the X into Y, because Y can be measured very easily and more accurately and more economically. So by measuring Y, how can we find X? We need a relation between X and Y, and that will be the characteristic of this sensor, that relation, है ना? जैसे ट्रांसफर, मतलब ये एक तरह से ट्रांसफर फंक्शन, सेंसर का ट्रांसफर फंक्शन होगा. So this is the requirement in every sensor based system, in every instrumentation system. The process by which we establish the relation between X. अब रिलेशन के लिए क्या चाहिए आपको? डेटा पॉइंट चाहिए, है ना? डेटा पॉइंट से आप स्टैब्लिश करना चाह रहे हैं ना कि y is equal to, एक्चुअली हम y is equal to fx नहीं, इनवर्स चाहते हैं, है ना? x is equal to fy. This is called inverse relation. This we want, so that we can put a y here and we get x. So by process by which we establish this relation, it is called calibration. Basically. So this is the thing which so in every sensor we will try to find out the relation between the output, and here in measurement system, in instrumentation system, the output is called response and input is called stimulus, or the parameter which we want to measure. So here in this case we'll try to establish a relation between the response, that is resistance, and input is strain. That is the requirement, because we are interested in measuring the strain using strain gauge, and the strain gauge is converting a strain into the resistance. Now we want a relation between resistance and strain, so that by measuring the resistance we can measure the strain. Is it fine to all of you? These are the basics of the instrumentation systems. जी, अगर कोई क्वेरी है, कोई क्वेश्चन है, कोई डाउट है, पूछ लीजिए आप.
क्लियर है सर.
बताइए, आगे बढ़ा जाए. मैं
क्लियर है.
कुछ बोलना चाह रहा है लेकिन मुझे सुना ही नहीं पड़ रहा है. हाँ भाई, somebody is asking something.
सर बोल रहे सर, क्लियर है सर, समझ आ गया सर.
Okay. So now, as you know, that strain gauge is a piece of wire. Now we are taking a piece of wire, and you know there is no strain without stress. So from the Hooke's law. So now this piece of wire, that we are calling it as a strain gauge. So this piece of wire is subjected to, it is strain. It is subjected to the strain. Means we are applying force this side and this side. So obviously this, whenever it is stressed, then it will get deformed within its elastic limit. So this wire, which is the wire whose dimension are given here, it will have certain resistance depending upon the dimensions and its material. So for the wire which is in unstrained condition, its resistance is equal to rho L upon A. Now when it is strained, the way it has been shown here, though obviously its length will increase as far as deformation due to the stress is concerned, its length will increase and its cross-sectional area will decrease. That's what I had shown here. This is, although means actually this change will be very small, and with the naked eyes you won't be able to identify. Like I will tell you, you will have the feeling like flyovers you must have seen, all of you must have seen. Now obviously when the vehicle and traffic goes upon it, then it got means it is strained, and strain means there is a deformation in the structure, but the structure is so massive that it is very difficult to identify it by your eyes. So for that purpose we use the sensors to find out the strain. So this is what exactly I am trying to. So wire is stressed because of this kind of deformation will take place in cross sectional area, in length. So now we are in process to derive the expression that how resistance and strain, resultant strains in this wire and this strain gauge element are related. So this is your initial value of the resistance, and now after when it is stressed, there is a deformation, then change of it. So S is the applied stress, because you know without stress there is no strain. So this I'm deciphering it. Rate of change of resistance with the applied stress is equal to rate, means I simply differentiated both the side with respect to stress. So this we can say that this change in resistance with stress is because of the change in length with stress, change in area of cross section with stress, change in resistivity with stress. This change in resistivity, you know what is resistivity? Can anybody tell what is resistivity? What is resistivity? बताएंगे भाई, क्या रेजिस्टिविटी क्या होती है? अरे पढ़ा तो होगा, कुछ तो जानते होंगे भाई रेजिस्टिविटी के बारे में.
Sir, it is the specific resistance offered by a particular element by a unit of its length.
सारी डेफिनेशन याद रखते हो तुम. और बताओ कोई क्या समझते हो रेजिस्टिविटी से?
सर
ये
इट इज
मटेरियल
मतलब ये
प्रॉपर्टी है जिसे वो
प्रॉपर्टी तो
अपोज
किसकी
करता है।
मटेरियल की सर?
This is
हम्म,
material property. That's correct. This is material property. And that's what I want to know. This is a material property. Now, if you are having a copper, so it will have certain value of resistivity. If you have aluminum, another. So if you are having a same length and cross-sectional area of a copper wire and same length and cross-sectional area of the aluminum wire, both will have different resistance because length and area is same, but the value of resistivity differs. So in this case, so main thing is that we should we can understand the change in dimension with the stress, but with the applied stress. But does material property also changes with the stress? What is your take upon it? Anybody? Does it change?
नो सर.
No, sir.
No, sir. No, sir. No, sir. Anyway, that is quite straightforward, but means we are basically yes and no is very means you cannot say unless until you had gone through the literature and you must have read all the things. Then you can, with confidence, you can say. So whatever feeble knowledge we are having about from that point of view, it is no, but we don't know actually. So this term is
सर
basically
डिपेंड करता है सर.
depend करता है
सर
कि
ये
हम
स्ट्रेन ये सर स्ट्रेन गॉज एक्सपेरिमेंट हमारा कराया गया, उसमें
डिपेंड
थोड़ा
करता
सा
है.
सर फार्मूला. हाँ यस, स्ट्रेन गॉज एक्सपेरिमेंट हमारा इसमें इलेक्ट्रिकल मेजरमेंट लैब में भी हुआ पिछला बार से. तो
अच्छा,
उसमें स्ट्रेन का वो जो कैलकुलेशन हो रहा था ईएमएफ के लिए, तो उसमें इक्वेशन में था.
कुछ था, आपने कुछ नोटिस किया है. एनीवे,
हाँ ये
सो
सर.
देखिए, कुछ लोग कह रहे हैं नहीं और कुछ लोग कह रहे हैं हाँ, तो इसका मतलब डिस्प्यूट है ना. तो वी आर taking it as it is because it is a disputed term. Then later on we'll see what can be done. So now in derivation, what so here how can we decipher this expression? Change in resistance of the strain gauge element with respect to stress is because of the change in length with the stress, change in area with the stress. Together these two change in dimension and change in dimension with stress, and then change in resistivity with stress. This is basically a disputed term, but we'll carry on as it is. At the end we'll see. Now different now here what we did, we took the fractional change in resistance delta r upon r, and then accordingly means we divided both the side by resistance. So finally this is coming out to be fractional change in resistance with the stress is equal to fractional change in length of the strain gauge wire with the stress, fractional change in area with the stress, and fractional change in resistivity with stress. So this is how our relation we are trying to establish. And here the change in strain gauge element resistance when it is stressed, what are the factors, what are the parameters on which it depends, that is shown here. Now further, to make it more simpler and have a good expression, but our objective remains same. We are trying to have a relation between the response of the strain gauge is basically the resistance, and the input or the stimulus is your strain. So this is our objective remains same, although we are still in between. So we'll further modify, because we are having cross-sectional area is your cross-sectional area is pi upon 4 d square. The diameter is the dia of the cross-section wire cross-section, and then we differentiated it with respect to the stress, and then we got this pi by 2 d and del d upon it. So change in area of cross section is because of the change in diameter, obviously. Now fractional change we have taken, so we divided both side by the area. Then finally we are able to find out the fractional change in area of cross section with the stress is equal to twice into fractional change in diameter into diameter with stress. So if anybody is having anything which you are not able to understand in these expressions, whatever I have written here, you can ask, please. Anyway, now we can write, we put this thing here. We put this thing, this expression. We replace area term by this expression, diameter term. So now we are having this. And you can see that this negative sign is coming only because of the nature of change. Here you can see that area is increasing. We took this change as a positive, and cross-sectional area is decreasing. We took this change as a negative. So that's what is the difference you can see here, and we carry forward it from the starting itself, because obviously here you see. So now then Poisson's ratio, for every material we are having a Poisson's ratio, and this Poisson's ratio is basically the ratio of the lateral strain to longitudinal strain. So in this case, delta D upon D, this will be a lateral strain, and delta L upon L is a longitudinal strain. And here minus sign we are taking because these two changes taking place in opposite direction. Your diameter is decreasing and your area, your length is increasing. So if increasing in change, this change we are taking positive, then this change is one positive and one negative will be negative. So this is what is the relation between the longitudinal strain and lateral strain. So now this lateral strain will replace by the longitudinal strain. So here we replace it by this, then we have got this expression. Now if this is true, then this is also true. What can we say? Fractional change, I'm deciphering this one. The fractional change in resistance of a strain gauge is equal to the fractional change in length 2 into Poisson's ratio into lateral changes length again plus the change in length, fractional change in length, and then plus fractional change in resistivity. So this if when subjected to the strain, now if these changes are discrete or it is large, then this can be replaced by delta R upon R, delta L upon L, and then so this is the final relation. That fractional change in resistance of strain gauge is because of the fractional change in length plus fractional change in area plus fractional change in resistivity. This represents, these two together represents the change in dimension, and this represents the change in property of the material, and this is still disputed. Now keeping it in the background, this expression still we are yet to our main objective is to relate the final response. This is your final response with the strain. Although here I'm not saying that it is established, but if you look upon this expression, so we had already established that, because this is nothing but the strain. So to directly correlate them, there is one very important characteristic parameter that is called gauge factor is associated with the strain gauge. So gauge factor is a very important specification for strain gauge. And what is it? So the gauge factor is the strain gauge is defined as fractional change in resistance of the strain gauge per unit strain. Fractional change, this is written here. Here it is defined, and here it is shown in a formula form. This is gauge factor. This is your gauge factor. Fractional change in resistance means delta R upon R per unit strain, that is delta L upon L. So this is called gauge factor, and this gauge factor is a very important specification for strain gauge. If you go to the market to purchase the strain gauge, then you have to tell vendor the minimum thing that you have to tell this what is the he will ask what should be the gauge factor. So this is gauge factor. Now this gauge factor, you can say that fractional change, with the help of this, fractional change in resistance is equal to gauge factor times strain. So this is how input and output are, your response and stimulus are related in case of strain gauge. Now we are coming back to this formula. So if we are saying that delta R upon R divided by strain, so it will be this. Now you see this term is because of the change in length, this term is because of the change in area, and this term is because of the change in resistivity. Now I'm coming to this is the final expression. Now I'm coming to clarify this. Yes, there is a change in resistivity when your material is strained, and here what is the reason? Actually, what happens that if you are having a material like wire of any means, generally it is conducting in semiconducting material. So if it is in relaxed form, then obviously all the bonds are in a relaxed form, and the bond forces are basically balanced in all the sense. And if we are talking about the because free electrons, they define the conductivity or the resistivity. Now when it is strained, then obviously bonds will get skewed and the bond forces are not entirely balanced. So additional forces are available when the material is basically strained. Then these forces obviously will hamper the free flow of electrons, because earlier there was no forces when the material is in relaxed form or your wire is in relaxed form. When it is strained, then unbalanced bond forces will come into the existence, and they will act upon the free electrons, and it will cause hindrance in flow of free electrons. Then obviously it will increase the resistivity, it will change the material property. So this effect is called piezoresistive effect. This effect is called piezoresistive effect. Change in resistivity of the material when it is stressed or strained is called piezoresistive effect. So you should not get confused with the piezoelectric effect. Piezoelectric effect is different. When we strain a material, piezoelectric material, then there is a polarization and voltage generation. So that is called piezoelectric effect. But here it is piezoresistive effect. So there is a change in resistivity of the material when it is strained. So this is what is called. So now our discussion means process. We try to correlate the change in resistance with the strain in a strain gauge. I explained this all through this derivation. If anybody is having any query, any question, you can ask, please. This is the best time. जी बताइए, किसी को कोई क्वेश्चन है, कोई चीज ऐसी है, यू कैन आस्क प्लीज. जी बताइए. हाँ भाई, कोई कुछ बोलना चाह रहा है? एनीवे
सर पीजो इफेक्ट एक बार और. अच्छा सर, ओके सर, नेक्स्ट स्लाइड में हम देख लेंगे.
देख लीजिए. ठीक है?
नहीं सर, वो थोड़ा सा आपका नोट कर रहे थे तो वही एक बार और थोड़ा सा पूछना था।
बताइए
आप
बताइए क्या?
सर वही सर, पीजो रेजिस्टिव इफेक्ट सर। सर ये जो इफेक्ट होता है सर, उसमें टेम्परेचर चेंज या फिर और कुछ इफेक्ट भी इंक्लूड होता है, या फिर सिर्फ क्या बोलते हैं सर, इलेक्ट्रॉन्स का ड्रिफ्ट
देखिए, देयर आर टू
वगैरह?
थिंग, देयर आर टू थिंग। अभी तो हम टेम्परेचर के बारे में कोई कोई डिस्कशन नहीं, वी आर नॉट इंटरेस्टेड इन मेजरिंग टेम्परेचर राइट नाउ, वी आर इंटरेस्टेड इन मेजरिंग द स्ट्रेन. Okay.
ओके।
So here situation is that a piece of wire made up of either conducting material, metallic material, or semiconducting material. So in that case, when you are straining your material, then there is a change in resistance. अब ये change in resistance किस किस वजह से हो रहा है, ये we try to find out it mathematically. Then we found that it is because of the change in dimension. So these two terms is because of the change in dimension, and this is because change in resistivity. Then we our point of discussion is that whether resistivity, that is a property of the material, it changes with the strain or not. So answer is that yes, it changes. It changes with the strain. And what is the physics behind it? That when your material is in the relaxed form, obviously, whether it is a semiconducting material or in conducting material, the conductivity or the resistivity is defined by the free availability of the free electrons to carry the current, to conduct the current, electric current. So if when the material is in relaxed form, so all the bonds of the material, their forces are basically balanced and there is no resultant force. But when it is basically when you are deforming the material, then bonds will also get deformed. Although I'm not saying that bonds are getting they are broken. No, they are not broken, but they are got deformed. So because of the deformation in bond, there are unbalanced resultant forces. That was balanced, all the forces were balanced when it was not deformed. So these unbalanced forces, bond forces, will obviously act upon the free electrons and it will hindrance the free movement of the electrons. So obviously it will affect the resistivity. So this phenomena that basically changes the resistivity of the material when it is a strain is called piezo resistive effect. It is called piezo resistive. जी बताइए.
थैंक यू सर, थैंक यू।
Or you should not get confused with the piezoelectric effect. Piezoelectric effect is altogether different thing. ठीक है?
यस सर, यस।
So piezoresistive effect is a change that is means summarized here. Now one more thing, in metals, piezoresistive effect is almost negligible. It is almost negligible. So in this case, we can neglect this term. In metallic strain gauges, this term is neglected. This term is neglected. and and then this will define your gauge factor. So that's what I had written. First two terms, there is change in. And piezoresistive effect is significant in semiconducting strain gauges because because of it, your gauge factor of semiconducting strain gauges is more than that of metallic. Means this term will be considered in semiconducting strain gauges, but in metallic strain gauges, this term is very small, so it is generally neglected. So in that case, gauge factor is 1 plus 2 into Poisson's ratio. But as far as semiconducting material is concerned, gauge factor will have all three terms together. So obviously your gauge factor is more for semiconducting strain gauges in comparison to metallic strain gauges. अब आप ये बताइए कि ये गेज फैक्टर ज्यादा होना चाहिए या कम होना चाहिए? Is it a desirable parameter or is it a non-desirable parameter? You apply your mind and you give me the answer. Respond your roll call, please. Roll number 1, roll number 2, roll number 3.
Roll number 2 present, sir.
3,
एक्सक्यूज में सर, रोल नंबर 2 प्रेजेंट ना?
हाँ भाई, बता, आप जब नहीं बोलेंगे तो हमने कर दिया, प्रेजेंट कर दिया आपको। रोल नंबर 3, रोल नंबर 4,
Present sir, roll number 4.
roll number 5, roll number 6,
Present sir, roll number 6.
roll number 7, roll number 8, roll number 9, roll number 10, Aman Malik, 11, 12, 13.
Present, sir.
13 is present.
Yes, sir.
14,
Yes, sir. 14.
15,
Present, sir. 15 present.
16, 17, 18, 19,
Present, sir. 19.
20,
Yes, sir.
21, 22,
Present, sir.
23, 24,
24 present sir.
25,
23 sir.
Present, sir. 25.
26,
23.
26, 27,
23.
Present, sir. 27.
28,
Present, sir. 28.
29,
Present, sir. 29.
30.
Present sir,
Any-
roll number 30.
30 present. Okay. Anybody between roll number 1 and 30?
Sir, roll number 7.
Roll number 7. क्या है, कितना है जी, बताइए।
23.
29. You're already present, Adnan. Okay.
Roll number
सर, ये
20.
saying 23 सर, उसका माइक ठीक नहीं है शायद।
23.
हाँ 23 बोल।
अच्छा ठीक, विवेक चौहान। Okay. Now I'm coming back to my question, my query. So what is gauge factor? Gauge factor, you already know. What is the significance of it, and should it be more or less?
Sir, it must be
So
high.
in the
Sir.
experiment we have saw that sir,
It must be
gauge factor of semiconductors are actually greater than the gauge factor of metals.
no.
That's all we know now.
Anyway,
Not the correct answer.
somebody else was telling something. This is your
Okay,
Sir,
sir.
gauge factor in a strain gauge must be high.
must be.
So it needs to be higher sir if
Higher,
you want
sir,
higher
higher.
sensitivity.
Why?
It needs to be higher
What will be
for
the
a good sensitivity.
what will be the advantage?
For good sensitivity.
What will be the it is,
Sir,
because it is
Sensitivity will be high.
Yes, you're correct. So that's what I want to know. You see, this is basically gauge factor is nothing but the sensitivity of the strain gauge. This is the ratio, the response, change in response to the change in input of the stimulus. This is so this is basically the sensitivity of the strain gauge, and we always want that our sensors should have good sensitivity, because measuring a small change is always a challenge. Accurate measurement is small change. So if your sensitivity will be high, so with change in input or the stimulus, you will get more change in output, and the change is more, so obviously measurement will be easy, and accurate measurement will be easy, and it will be economical also. So that's why we always want that gauge factor should be high, and gauge factor, obviously gauge factor of the semiconducting material will be more than gauge factor of the metallic material because of the piezoresistive effect. Because piezoresistive effect is not pronounced, it is negligible in case of metallic strain gauges, and it is good in semiconducting strain gauges. So But still, you see, metallic strain gauges are preferred over semiconductor strain gauges. What is the reason? Anyway, this is the question that requires some literature or some literature survey or some study. So I want that you should try to find out why
So because of piezoresistive effect.
piezoresistive effect is good.
नहीं सर, आपने जो क्वेश्चन पूछा कि सर व्हाई मेटल्स आर प्रेफर्ड ओवर सेमीकंडक्टर मटेरियल इन सर स्टेन इन गॉज, मतलब सर गॉज फैक्टर मेटल्स का क्यों ज्यादा होता है सेमीकंडक्टर के एज
यार मैं
कंपेयर
तो
टू?
कुछ समझा रहा हूँ, तुम कुछ समझ रहे हो। योर
नहीं सर, मतलब गॉज फैक्टर मेटल का क्यों ज्यादा होता है सेमीकंडक्टर से, तो मैंने बोला सर कि सर रीजन शायद पीजो
मेरी
रेजिस्टिव
सुनोगे
इफेक्ट हो
भाई,
सकता
मेरी सुनने की पसंद करोगे?
है। ओके सर, यस सर, बोलिए
Who
सर।
is saying that the gauge factor of the metallic strain gauges is more than the semiconductor? It is other way around. तुम्हें समझ ही नहीं आया मैं क्या पढ़ाया जा रहा है? You see, as far as the gauge factor is concerned, this your third term is not present. It is very small in case of metallic strain gauges, whereas it is very much so. The semiconductor strain gauges obviously will have more gauge factor than the metallic strain gauges. That is the question. That's what I had written. That's what I had written here.
ओके सॉरी सर।
So here, this is a piezo-resistive effect is significant in semiconductor strain gauges, and because of it, the gauge factor of semiconductor strain gauges is more than that of metallic counterpart. Is it fine? फिर हमने पूछा गेज फैक्टर ज्यादा होना चाहिए, कम होना चाहिए. Then gauge factor basically represents the sensitivity of the strain gauge. So it is always desirable that the sensitivity of the measurement system should be high. और इसकी ज्यादा होती है तब भी क्यों मेटेलिक स्ट्रेन गेजेस ज्यादा यूज करते हैं? दैट इज द क्वेश्चन. समझ में आ गई भाई? अब इसको जरा सा आप लोग पढ़िएगा और बताइएगा, और जल्दी से ये छोटा सा प्रॉब्लम है इसको सॉल्व किया हुआ है, इसको देख लीजिए, देन यू विल हैव द आइडिया. बाय द टाइम आई विल टेक you go through it, and if you are not able to understand anything, you should ask me. By the time I will finish your attendance, respond your roll call, please. Roll number 31.
Present, sir.
Mohammed. 32.
Mohammed
Yes sir,
Fatah, present.
32 present सर.
31 32 दोनों को प्रेजेंट कर दिया.
सर मैं 32 कल भी प्रेजेंट था सर, माइक वर्क नहीं कर रहा था उस टाइम, नेटवर्क इशू था सर.
आपको फिर प्रेजेंट कर दिया, कल भी कर दिया.
ठीक है, थैंक यू.
रागिब अली 33.
Present sir, roll number 33.
35. Rasik Firdaus.
Sir,
This numerical problem, you will have the feel that how this strain is measured or the change in resistance is estimated. So you see that apart from the Hooke's law, first of all, you estimated the strain because of the you are using a material with the certain value of the Young's modulus of elasticity, and then you are applying certain force, certain stress, and resultant strain you have calculated. It is 50 microstrain. Now from the gauge factor, obviously gauge factor is the known specification, is the specific important specification of the strain gauge. So you know this gauge factor of the strain. Now this, if you means question is like that, if you are having a strain gauge of this gauge factor, your gauge factor is 2, then when you will subject this strain gauge to the strain of the 50 microstrain, then how much will be the output or the response in terms of the fractional change in resistance. So you know the formula that gauge factor is ratio of the fractional change in resistance and strain. So here you can find out the fractional change in resistance that is coming out to be this much. And then if you are interested in finding out, so this is coming out to be the 0.1% or 0.001 ohm. So this is this, and you can see that this is the real situation. The change is very small, so it is always desirable that the gauge factor should be high. But still, your semiconducting strain gauge is having highest gauge factor still, but it is not preferred. So that is my question. So if anybody is having anything which is not clear to you in this numerical problem, you can ask, please.
No, sir, it's clear.
So now I'm closing my lecture for today here. Thank you very much for listening and joining.
Thank you so much, sir.
Welcome.